What happens when you take the power of an entire data center and shrink it down to something that could literally sit next to your coffee mug? Well, NVIDIA just did exactly that with the DGX Spark, and honestly, it's causing quite a stir in the AI world. This isn't just another mini PC trying to look important. This is a legitimate supercomputer that delivers 1 petaflop of AI performance in a form factor smaller than most laptops. I've been diving deep into this machine for weeks now, and I can tell you right off the bat that this thing is going to change how we think about AI development. But before we get ahead of ourselves, let's talk about why this matters so much and whether it's actually worth the hype that's been building around it. The timing couldn't be better either. We're at this inflection point where AI models are getting bigger and more capable, but developers are stuck with this fundamental problem. They want to experiment with cutting-edge models, but they're constantly hitting hardware limitations. Most laptops can barely run a decent language model, and renting cloud GPUs gets expensive fast when you're iterating on ideas. That's where the DGX Spark comes in. This compact powerhouse is built around NVIDIA's GB10 Grace Blackwell superchip, and it's designed to solve exactly these problems. We're talking about the ability to run models with up to 200 billion parameters right on your desk. That's the kind of capability that was exclusive to major research labs just a few years ago. But here's what really gets me excited about this device. It's not just about the raw compute power, though that's certainly impressive. It's about democratizing access to serious AI development tools. When I see researchers at universities getting their hands on these machines or artists using them to create AI-powered installations, it becomes clear that we're witnessing something bigger than just a new product launch. Let me paint you a picture of what this machine actually looks like. The DGX Spark measures just 150mm by 150mm by 50.5mm. To put that in perspective, it's smaller than most textbooks, but packs more AI computing power than systems that used to fill entire server racks. The design is sleek and functional, with a distinctive gold-colored metal chassis that somehow manages to look both professional and approachable. The front features what appears to be foam, but is actually a hard material that allows for optimal airflow. The engineering here is remarkable when you consider the thermal challenges of packing this much computational power into such a small space. The bottom has a large ventilation system and substantial rubber padding that keeps the system stable on any desk surface. Where things get really interesting is on the back panel. This is where NVIDIA has packed an impressive array of connectivity options. You've got the standard power button, a USB-C port for power delivery, 3 USB 3.0 20 Gbps Type-C ports with DisplayPort Alt mode, and an HDMI port for display connectivity. But the real magic happens with the networking capabilities. There's a Realtek-based 10 gigabit Ethernet port, which is already more than most people have in their home setups. However, the standout feature is the pair of NVIDIA ConnectX-7 200 gigabit Ethernet ports using QSFP6 connectors. These aren't just for show, they're central to the entire value proposition of the system. These high-speed ports support RDMA networking and enable what might be the coolest feature of the DGX Spark. You can literally take a copper direct attach cable and connect 2 Spark systems together to effectively double your compute power and memory capacity. Suddenly you're working with models that have up to 405 billion parameters, which puts you in the same league as some of the most advanced AI research being done today. The heart of this system is the GB10 Grace Blackwell superchip, and this is where NVIDIA has really pushed the boundaries of what's possible in a desktop form factor. This isn't just a repurposed laptop chip or a scaled-down server processor. It's a purpose-built AI accelerator that combines CPU and GPU functionality in a unified architecture. The system comes with 128 gigabytes of coherent unified system memory, which is absolutely crucial for running large AI models. Most consumer hardware struggles with memory limitations when dealing with modern AI workloads, but the Spark has enough memory to handle serious development and inference tasks without breaking a sweat. What really sets this apart is the software stack that comes pre-installed. NVIDIA has included their complete AI development environment, including frameworks, libraries, and pre-trained models. This means you can literally unbox the system and start working with state-of-the-art AI models within minutes. No lengthy setup processes, no driver compatibility issues, no hunting down obscure dependencies. The performance numbers are genuinely impressive. We're talking about theoretical FP4 tops performance that reaches into petaflop territory when you factor in the sparsity features. For context, this is the kind of performance that would have required a small data center just a few years ago, and now it's sitting quietly on your desk drawing reasonable amounts of power. But let's talk about real-world applications because raw performance numbers only tell part of the story. I've been watching how different communities are adopting this technology, and the use cases are incredibly diverse. Universities are using these systems to give every graduate student access to serious AI compute power. Startups are prototyping new AI applications without having to worry about cloud costs spiraling out of control. Artists and creative professionals are particularly excited about the Spark. But there's something powerful about having this level of AI capability available locally without depending on internet connections or dealing with the latency of cloud-based services. We're seeing installations where the Spark serves as the brain for AI-powered art pieces that generate new content continuously. The robotics community is also embracing this technology in interesting ways. The ability to run complex vision models and reasoning systems locally is opening up new possibilities for autonomous systems that don't need constant connectivity to function effectively. From a development perspective, the Spark addresses one of the biggest pain points in modern AI work, which is the iteration cycle. When you're fine-tuning models or experimenting with different approaches, having local compute power means you can iterate much faster than if you were dependent on cloud resources or shared computing clusters. The networking capabilities I mentioned earlier become particularly interesting when you start thinking about collaborative development scenarios. Teams can set up small clusters of Spark systems that work together on larger problems, creating a sort of distributed AI development environment that bridges the gap between individual workstations and full-scale data center deployments. However, it's worth noting that this system isn't without its challenges. Early users have reported some teething issues, particularly around display connectivity and driver compatibility with certain configurations. These are the kinds of problems you'd expect with any first-generation hardware, and NVIDIA has been responsive to community feedback in addressing these issues. The pricing and availability situation is also worth discussing. While NVIDIA hasn't released official pricing details publicly, the system is positioned as a professional development tool rather than a consumer device. The company is rolling out availability through authorized partners and focusing initially on developers, researchers, and organizations with serious AI development needs. What's particularly interesting is how this fits into NVIDIA's broader strategy around AI democratization. The Spark isn't just a standalone product, it's part of a larger ecosystem that includes software tools, development frameworks, and community resources designed to make AI development more accessible to a broader range of users. The implications of having this level of AI compute power available in a desktop form factor extend far beyond just convenience. We're potentially looking at a shift in how AI research and development happens. Instead of being concentrated in major tech companies and well-funded research institutions, serious AI work becomes accessible to smaller organizations, individual researchers, and creative professionals. This democratization effect could accelerate innovation in ways that are difficult to predict. When more people have access to powerful AI development tools, we tend to see unexpected applications and breakthrough approaches that wouldn't have emerged from traditional research environments. The DGX Spark also represents a significant step forward in edge AI capabilities. While much of the current AI infrastructure is built around cloud-based services, there's growing recognition that many applications benefit from local processing, whether it's for privacy reasons, latency requirements, or simply the desire to have AI capabilities that don't depend on internet connectivity. Edge AI is becoming increasingly important. Looking at the broader market context, the Spark arrives at a time when AI hardware is experiencing rapid innovation. We're seeing new chip architectures, novel approaches to memory and storage, and increasing focus on power efficiency. The Spark demonstrates that it's possible to pack serious AI capabilities into increasingly compact and accessible form factors. For organizations evaluating their AI strategy, the Spark presents some interesting possibilities. Instead of making large upfront investments in cloud infrastructure or trying to build out data center capabilities, teams can start with one or more Spark systems and scale their approach as their needs evolve. This lower barrier to entry could be particularly valuable for companies that are just beginning to explore AI applications in their business. The educational implications are also significant. Universities and training programs can provide students with hands-on experience using professional-grade AI development tools without the logistical challenges of managing shared computing resources. This could help prepare the next generation of AI professionals with practical skills using cutting-edge hardware and software. So is the NVIDIA DGX Spark worth the hype? Based on everything I've seen, the answer is a qualified yes. This isn't just another incremental improvement in AI hardware, it's a genuine step change in what's possible for individual developers and small teams. The combination of serious computational power, comprehensive software stack, and desktop-friendly form factor creates new possibilities that simply weren't available before. However, success will ultimately depend on factors beyond just the hardware capabilities. Community adoption, software ecosystem development, and pricing accessibility will all play crucial roles in determining whether the Spark achieves its potential as a democratizing force in AI development. What's clear is that NVIDIA has created something genuinely innovative with the DGX Spark. Whether you're a researcher pushing the boundaries of AI capabilities, a developer building the next generation of intelligent applications, or an organization exploring how AI can transform your business, the Spark offers unprecedented access to professional-grade AI development capabilities in a package that fits on your desk. The future of AI development is increasingly moving toward distributed, accessible, and democratized approaches, and the DGX Spark represents a significant milestone in that evolution. It's not just about having a powerful computer, it's about having the tools to turn imagination into reality right at your fingertips.